Hello students, already I have shared first 6 questions of exercise 7.2 in yesterday's talk video. So today I will start with question number 7 of the same exercise, that is your exercise 7.2, in which you are given with a triangle right angled at A of 90 degree and your AB is given equal to your AC. So write that AB is equal to AC. This is given to you and you need to find your angle P comma angle C that you need to determine. So very simple question from your triangle angle sum property of if your AB is equal to AC, so this implies angle B will also be equal to angle C, say x degree each, let us say. So if this is x, this is also x. Converse of your isosceles triangle angle property. Two sides are equal, then their opposite angles are also equal. Now simply apply the triangle angle sum property. Angle A plus angle B plus angle C is equal to 180 degree. So here it is 90 plus x is equal to 180. So this implies 2x is equal to 90. So what is x is equal to 45 degree. So both the angles, so therefore angle B as well as angle C will be equal to 45 degree each. So I hope all of you can do that very comfortably. It's a very simple problem at last, based upon your isosceles triangle angle property as well your triangle angle sum property also. Then the last question is, you are given with an equilateral triangle ABC. This is given to you. AB is equal to AC is equal to BC. To prove that each angle of the equilateral triangle is of 60 degree. Now in this proof again you apply the property of your isosceles triangle as AB is equal to AC. So what does this imply? Angle B is equal to angle C. Again you say x and give it number 1. Also, if you see, your AB is equal to BC. AB is equal to BC. So if AB is equal to BC, then your angle A will also be equal to angle C. So give it number 2. Now from 1 and 2. Here you said C is equal to B. Here you are saying C is equal to A. So can I conclude that angle A is equal to angle B is equal to angle C, that is equal to x degree each. So why I am discussing the solution with you? See, this is a question of section C at least, that is of 3 marks. You need to write down the steps. Sometime I have seen that directly the students, they are writing in one line only. We know that each angle of the equilateral triangle is of 60 degree. That is not the purpose. I am sharing with you. Most of the time we are focusing about the answer only. Answer is known means everything is known. No, not at all. You see, somewhere now you are supposed to prove this. Why do we say that each angle, or how we have to prove this, each angle of the equilateral triangle is 60 degrees. So that is the purpose. Now I have proved each angle is x. So therefore your x plus x will be equal to x plus x plus x will be equal to 180. That is by triangle angle sum property. So 3x when will be equal to 180, then x will be equal to 60 degree. So in each A as well B and C, you can write then will be of 60 degree each. So that is the procedure you need to follow somewhere to write the answer of this. So that is the end of your exercise 7.2 also. And in 7.1 as well as 7.2 we shared the application of your SSS, SAS, ASA, AAS as well your RHS. And another thing which we did, that was the property of your isosceles triangle and its converse. Now the last exercise of your this congruent triangle, somewhere is inequalities of the triangle. Inequalities. This is the factor now. We have to discuss inequalities in triangle. I hope you touched this part somewhere in your class 7, where you did one property, if you remember, that sum of the two sides is greater than that of the third side, is greater than that of the third side. I'm just taking you to the topic. Why do we say inequalities? So here you just can see, if you have done this property somewhere, sum of the two sides is greater than that of the third side. It means inequality somewhere I'm talking about. So this is the first point, which already if you have shared will take you to the topic, that is inequalities in triangles. So the points to remember here, of course, this is there, sum of the two sides. So you remember also that difference of the two sides is less than that of the third side, is less than that of the third side. This is the second point you need to recall. And the very important point which I will be taking in application part of the exercise questions of this 7.3, that is your angle opposite to the longer side is the greater angle. This is very important. Most of the questions are based upon this, and its converse. Angle opposite to the longer side is the greater angle. Suppose I am talking about any triangle here, ABC. So what does it means? The angle opposite to the longer side. Suppose if I am saying here it is 8, here it is 2, and here it is 3. And the question is, which is the greatest angle? So immediately our answer should come, angle A is the greatest angle. Why? Because the length wise, the greatest length is here BC. So that is the purpose. Angle opposite to the longer side is always a greater angle. So the shortest angle here you will be finding is C, and the middle angle will be here angle B. So you can write the angles in ascending order as well as in descending order, which can be the part of your objective questions also, that is of section A as well as of section B. So in that way the property is very important, and you need to keep a watch upon this property. And then the last again is side opposite to the greater angle. Greater angle is the longer side. That is the converse of your this previous talk. Means if you are talking about a triangle here, this is the angle of 60 degree, this is the angle of your 90 degree, and this is of 30 degree. So you know, if this is A, this is B, and this is C. So the greatest angle here is A. So the side opposite to A is what? BC. So BC is the greatest side, longest side here in this triangle. So side opposite to the greater angle will be the greater. So if I will write the sides in ascending order, that is the greatest side will be BC, second length opposite to 60 will be AC, and third length will be that is of AB. So length wise BC is the greatest side, AC is the second number, and AB is the third, as per the angles property. So if the angle is greater, then the side opposite to that will be the longer side. So keep these points in your mind, make a note of all these 4 points, but these two are the key points to have the solution of your this exercise 7.3. So very interesting questions are given in your exercise 7.3 and arranged in a systematic manner also. That is the beauty of your NCERT exercise questions. If you proceed in a sequence, you will find that the questions are interconnected with each other and moreover are arranged in a manner of your easy to complex manner. So in 7.3, then you'll start with your first question. There the first question is triangle, 7.3, already I have finished. 7.4 is the triangle, 7.4 is the exercise related to your inequalities. So 7.2, last two questions were left, that's why I shared those two questions with you first. Now I'm coming to the 7.4 because 7.3, yesterday we have finished all the questions. So 7.4 is based upon your NCERT. Show that in a right angle triangle, the hypotenuse is the longest side. Very interesting, very interesting. A, B, C. This is the right triangle. So I will take your time to give you the explanation of these questions. So within today's lecture and tomorrow's lecture, I will finish this exercise for you. So see, the first question, you need to prove hypotenuse is the longest side in a right triangle. And we are very much known to this fact. But now the question is, how to prove this? And that is the part, or what do I feel is, we are finding it difficult to prove. That is only the difficulty with the syllabus of class 9. Now what happens? If AB is the greatest side, that is the hypotenuse in a right triangle, I know that AB square is equal to AC square plus BC square. Already I have shared with you, if you are not finding it convenient to write your answer directly, you can think in direct way also. That is the contradiction method. To prove that AB is the longest side, given triangle ABC, angle C, suppose I am taking is equal to 90 degrees. So therefore what happens? AB square will be equal to AC square plus BC square. I hope all of you will be agreeing. Hypotenuse square because is always equal to perpendicular square plus base square. I said, say this is not the longest side. AB is not the longest side. Proof, contradiction method. Let us say AB is not the greatest side. Let us assume. So, suppose I am saying BC is greater than that of AB. Now what happens? If BC is greater than that of AP, BC is greater than that of AB, this implies the angle opposite to the BC is what? Angle A will be greater than that of angle B, or greater than that of C, because I am comparing BC with AB, so opposite to AB there is angle C. Do you agree with me? As I said, the property, the angle opposite to the longer side will be the greater angle. Now I am comparing BC and AB. So opposite to BC, the angle A is there, and opposite to AB, angle C is there. So if BC is greater than that of AB, then opposite to BC, angle A is there, and opposite to AB, angle C is there. So definitely angle A should be greater than that of angle C. That means your angle A is greater than that of 90 degree. Now you let me know, is it possible? Is it possible? Give a second thought, please. Surely you'll be getting the answer. No, not at all. Why? What happens? What happens here? If your angle A will be then greater than that of 90 degree, the sum of two angles only, that is of C as well as of A, will exceed 180 degree. And in that way, nowhere the possibility remains of the triangle ACB will not remain a triangle if the sum is exceeding than that of 180 degree. So my assumption is wrong. My assumption is wrong. Hence AB is only the greatest side here. Why? Because AB is the hypotenuse. Similarly, you can compare your AC also. The same way, your this B will be greater than that of 90 degree, which again will not be possible. So no need to write that again. One is enough from your answer point of view, as I have given to you here. So if A becomes greater than that of 90, sum of the two angles will be exceeding the sum of triangle's angle, that is 180 degree. So triangle is not possible. Hence my assumption is wrong. So only the hypotenuse can be the greater side in a right triangle. I hope that is clear to you all. Now directly I will take you to the last question of this exercise, because these two questions are interconnected somewhere. That is, show that of all line segments drawn from a given point, not on it, the perpendicular line segment is the shortest length. So that also you did somewhere in class 7. Suppose if any line is there L, and here is any point P. From this point, the procedure to draw the perpendicular, you have to draw the arc of any suitable radius which meets at, suppose at A and B, open the compass more than half of AB and cut the arcs from A as well as from B. I hope you did this construction, and then you are drawing the perpendicular to this line. I'm simply sharing the way of constructing. That is the question which I need to discuss with you at last of this exercise. That is your last question somewhere, question number 6. What is the question? Question is if any line is given to you and any point not lying on that line, outside that line, and I said, suppose that is the point P. If I draw the line perpendicular to this, I am saying PL is the line drawn perpendicular to L. In comparison of other lines, suppose PM and PN are also the other lines I have drawn. So what I have to prove is perpendicular length is the shortest length. Perpendicular length is the shortest length. So how you can say that? Now you come back. In triangle PLM. Do you agree with me that PM is greater than that of PL? Of course. If even I move hairline, suppose here at I'm taking it PA, don't you feel that PA is also greater than that of PL? This is number 1, this is number 2. Why? If this PA I have drawn, I'm saying even hairline difference if you will make, so that will be a right triangle somewhere. Don't you feel that PAL is the right triangle? And here the vertex is of 90, so opposite to 90, the hypotenuse is always there. That's why I'm taking this even straight way after question number 1, because we proved their hypotenuse is the greatest side. So in this triangle, this is of 90 degree and PA is greater than that of, because I have to draw the lines only from P to L. So two possibilities I'm comparing, PL with PA. So if I will compare, so my PA will always be greater than that of PL. My PM will always be greater than that of PL. My PN will be greater than that of PL, and so on and so on. You keep on drawing as many lines you want to draw from P to L. All the times with respect to this PL, the other lines will be playing the role of hypotenuse, which always will be greater than that of your PL. So that's why we do say that if the line drawn from the point not lying on the line is perpendicular, will always be the shortest length to that particular line. So remember that this is the way I have written the proof to you. Hardly a 2 marks question is this, but how to prove? Simply you just draw a triangle in terms of PL, and opposite side will always be the hypotenuse, and if you compare the hypotenuse with the perpendicular, will always be greater, so perpendicular length will always be the shortest length. So that's all for today. Remaining question I will come with the solution tomorrow. Thank you.